Welcome back to our session. We're still looking at calculations involving Coulomb's law, but now we'll try and look at a question that involves, interpretation of a graph, because a graph in many ways represents the relationship between, the dependent and the independent variable. Now let's look at this question and see what it's all about. Right. So in an experiment to verify the relationship between electrostatic force and distance, right, between two identical positively charged spheres on a graph was obtained. So any experiment, its purpose is to verify a scientific fact. So what is it that we want to establish here? We want to establish the relationship that exists between electrostatic force and the distance, right? So this has a lot to do with Coulomb's law, right? Okay, so this is the graph that was obtained. Take note, this is the reciprocal of the square of the distance versus the electrostatic force. So what do we know? We know that the electrostatic force of attraction or repulsion, right, is inversely proportional to the square of the distance between the charges, right? But also, we can safely say that the electrostatic force of, in this case, repulsion, because these are positive charges, they tend to repel each other because they are like charges, is actually directly proportional to the reciprocal of the square of the distance, right? So take note, we can talk about the relationship between the square of distance and electrostatic force, as well as the reciprocal of the square of the distance and the electrostatic force. Take note of that, right? So this graph is electrostatic force versus the reciprocal of the square of the distance, right? Okay, so the question says write down the dependent variable in the experiment, right? So in any experiment, there are three categories of variables. We've got the independent variable, the one that's going to be manipulated. As a result of that, we want to see how the other quantity responds, or the response variable, which is the dependent. So in this case, what happened is that the distance between the two charges was varied. But remember, in this case, we wanted to see how changing the distance actually affects the electrostatic force. So the response variable in this case is the electrostatic force. So the dependent variable is electrostatic force, okay? So, and again, from the graph that's given, the electrostatic force is given on the vertical axis. So always the response variable or the dependent variable is always plotted on the vertical axis, straightforward. Right, okay, so this is our graph that was obtained, and then the follow-up question says, what relationship between electrostatic force and the square of the distance exists? So we know that electrostatic force, okay, from Coulomb's law is inversely proportional, okay, to the square of the distance between the charges, right? So it's inversely proportional. How do we represent this mathematically? We are saying force electrostatic is inversely proportional to the square of the distance, right? At the same time, we can say that the electrostatic force, in other words, is directly proportional. We are still talking about the same relationship, all right? It's directly proportional, another way of looking at it, to the reciprocal, okay? Okay, of the square of the distance, okay, of r squared, right? So here what we are saying is that this is actually the reciprocal, okay, which is directly proportional to the electrostatic force. So in other words, we can look at it in terms of the electrostatic force being inversely proportional to the square of the distance. But here we are talking essentially about the reciprocal of the distance squared, right? So it's very important to understand this mathematical relationship, right? Okay, and then the question says use the relationship shown in the graph to predict what will happen between the distance to the distance between the charges if the force was to be double, right? So what do we know? We already know that the electrostatic force of attraction or repulsion is inversely proportional to the square of the distance, right? So at the same time, we are saying that the reciprocal of the same electrostatic force is actually directly proportional to the reciprocal. So this is the reciprocal of the square of the distance, okay? Of the square of the distance, right? So which is the 1 over r squared. So if force has to be doubled, right? If the force is going to be doubled, what would have happened to the distance? Let's think of it initially in terms of increase, decrease, or remain the same, okay? So if the force becomes double, it means to some extent the distance between those two identical charges was, reduced or decreased, right? So it must be multiplied by a factor that is less than 1, okay? But remember, in principle, we are saying that according to the Coulomb's law, the electrostatic force is actually inversely proportional to the square of the distance. So if the force is to be doubled, what does that mean? It means then, now the force, let's say the initial force was F, okay? Then after, decreasing the distance, then the force becomes 2F, okay? So now what has happened, the force is twice what it was. So what would have happened in terms of, the distance? Because remember, if we say 1 over 2, it means if we have the distance, the force will be 4 times as greater. So we need to actually get the square root of that distance. So this is the factor by which we multiply, the distance. So in this case, this works out to 1 over root 2 of the original distance. Then this translates to double the force. So this has a lot to do with the mathematical relationship that exists between electrostatic force and the reciprocal of the square of the distance, right? Okay. And then we want to use the information on the graph to calculate the charge on each sphere. Now, this is a multi-step type of a problem, okay? Now, the first thing that comes to mind, there is a linear relationship that exists between electrostatic force and the reciprocal of the square of the distance. So if we calculate the slope, what exactly does it give us? Now, let's determine the magnitude of the gradient or the slope, okay? So according to this graph, if you look at the graph, you'll see that the electrostatic force is on the vertical axis, and then the reciprocal of the square of the distance is on the horizontal axis, right? Okay, so the slope in this case, it will be change in electrostatic force, okay, divided by the reciprocal of the change of the square of the distance. In this case, if we go to, the graph, okay, we need to identify any 2 points. So remember, this is a line of best fit. So it's ideal that we take a point that is actually on the graph, to represent the gradient correctly. So we'll take the line, because this is directly proportional, we'll take these 2 points. In this case, this is 0,026. So the gradient or the slope in this case is going to be equals to, we'll take the change in y. In this case, is 0,026, 0,026. Okay, minus 0, which speaks to the origin, divided by the change in the reciprocal of the square of the distance, which is, in this case, 5.6, okay, minus 0. Okay, so from this, we'll go to our calculator, okay, just to verify that. So this gives us the change in the vertical axis, 0,026. Less 0. It's important that we show the substitution by 0 because the marks are given for substitution. Then 5.6 minus 0 as well, okay? What do we get from that? We get that value. So we get 4,64 times 10 exponent minus 3, okay? 4,64 times 10 exponent minus 3. 4,64 times 10 exponent negative 3, okay? So the value or the units are in Newton meter squared, Okay, this is what the slope is all about. And then the question wants us to calculate the charge. Remember, these charges are actually identical. So what do we have here? We've got F electrostatic R squared is equals to K Q squared. Okay, now we have this slope 4,6, just to go back, 6,4, okay, times 10 exponent minus 3, okay, exponent minus 3. We know the value of the constant 9 times 10 exponent 9, then Q squared. Why are we saying Q squared? These are identical, so it's Q by Q. Then if you do the maths, you'll get a Q value of equals to 7,32 times 10 exponent negative 7 coulombs. Right, so this question had a lot to do with the interpretation. But remember, beyond just reciting the Coulomb's law, it's also important to understand the relationship that exists between the product of the charges and the electrostatic force at the same time, how distance, square of the distance relates to the electrostatic force. So beyond this, we also need to try and practice as many questions as we can so that our level of confidence is also, better in terms of our preparation for examinations. So that's the time we had for today. For myself, Themba Ngube, it's cheers and bye-bye for now.